We're back, folks. So on our journey to understanding movement, remember we talked about origin and insertion, we talked about muscle actions, and then we ended with levers. Now we're going to go inside the muscle themselves. And that means we have to understand the arrangement of those muscle fibers. So we have to recall that fascicles are groups of muscle fibers that are bound by perimysium. Remember that, okay? And based on these fascicles and how they're actually going to be shaped, we can understand something about how the muscle works. Shape is important, and structure is going to help dictate function. So when we're talking about movement and we're talking about contraction and going from the insertion, getting closer to that origin, then guess what? These fascicles or these groups of muscle fibers are going to help us understand the length of a contraction and also the strength of the contraction or the amount of force that's going to be generated. So let's go ahead and get into that. The length of fibers is going to tell us the length of a contraction, while the number of fibers, how many there are, is going to tell us the strength of a contraction. Think about this when it comes to the length of the fibers. If you have a very long fiber versus a very short fiber, a very long fiber, you're going to have your insertion, you're going to have your origin, and your goal is to contract, right? And so you're also going to have a longer contraction because you have a longer distance between the origin and insertion. Makes sense? Versus when you have a short fiber, you have your origin and you have your insertion here, you're going to have a shorter contraction because why? Well, it can't shorten that much. The insertion and origin are kind of close to one another, so yes, there will be some type of contraction, some type of shortening, but it won't be that much. Think about the number of fibers and the strength of contraction. Okay, well, if you have a large number of fibers, say this amount of number of fibers here, versus a small number of fibers. Small number of fibers, yes, you're going to get some type of contraction, but it's usually not going to have as much force that's being generated. Whereas when you have a lot of muscle fibers coming together, yes, you're going to have a total force altogether, and that means you're going to have a stronger contraction. We're talking about fascicles. We know that they're groups of muscle fibers, and those muscle fibers run the entire length of that entire muscle fascicle, okay, or the entire length of the muscle itself. They're these long, long, long cells, right? They have multinuclei. We're going back to that information from chapter 9. And so when you have a lot of those muscle fibers together, that can help you understand, hey, the more fibers, the more strong that contraction is going to be. So what we're essentially saying is that how the fascicle is arranged is going to help us either optimize length of the fibers or the number of fibers, meaning strength of the contraction or length of the contraction. So let's get into some details of different arrangements. All the arrangements here, 1 through 3, parallel, convergent, and circular, are going to be focused on length of a contraction. Whereas when you're talking about 4 through 6 or the pinnate type of number of fibers, we're going to be focused on the strength of contraction or, of course, the force of that contraction, how strong it is. Okay? And yes, there are going to be some that do both. They can actually have a long contraction and be very, very strong. So we'll see those as we go along. We can come up with some generalizations like, okay, well, the more force you have, the larger the strength of the contraction, the stronger the strength of the contraction, then the less length you have. That can be an option, or vice versa. The more length you have, the length of the contraction, the less force you're going to have. That means the strength of the contraction is going to be a little bit smaller, right? And that is true. But again, some of them can also be both. Get to it. Let's talk about the length of the fibers. Remember, we can also think of range of motion. It's going to have a larger range of motion because they're longer. And the first type is going to be parallel. That means these fibers are going to run the length of the muscle. So one example is going to be our sartorius muscle. It's very long and thin, as you can see, very long and thin. And yes, it's going to have a long amount or a large length of contraction. So it's going to be a longer contraction. But because it's very thin, it's not going to be having that much contractual force. Okay, so yes, it's very long, but because there's not that many fibers here, it's not going to be that strong. That's sartorius muscle here, going from our hip to our tibia. Okay. Next, a subgroup of the parallel type of fibers is the fusiform fiber. And that means it's going to be spindle shaped. So when we think of a spindle, remember, we have the narrow ends and then we have that kind of thicker, wider end in the middle. And so one perfect example of that is going to be our bicep brachii here. And as you can see, our bicep brachii, we know it's going to have a origin at the shoulder and insertion around the forearm. And it does have that thickness in the middle, so it definitely will be spindle shaped. Now, let's think about this here. If we know it doesn't have as many fibers that's going to be at the edge here, for example, like this is way more narrow, so it's probably going to have less number of fibers. But in the middle, you do have an increase in number of fibers because it does get more thicker or wider or fatter, whatever you want to say, okay? So when it comes to these biceps brachii, you're probably going to have some amount of ability to pack some force inside this muscle, right? So the length of the fiber is still going to be the same, right? They're going to be very long, so that means you're going to have a good long contraction, but the number of fibers can increase because we have that that fatter area in the spindle here. And because of that, it's going to pack more force. So this one is kind of both, right? I mean, yes, you have a long length of the fiber, but also because you have that wider kind of fatter portion of the spindle shape, it can increase the number of fibers there and allow you to have more strength. Let's go ahead and get into conversion. Now, convergent meaning that you're going to have an origin that's larger than the insertion. One example is going to be our pectoralis major muscle here. So our origin is actually going to be, again, near the actual sternum and some of the ribs, and our insertion is going to be on the humerus, as we can see. And what do we notice? One is very big. It takes up a lot of space, right? So it takes up a lot of space here. And we have all these fibers that are kind of going towards this tiny little insertion. This is our insertion area, this is our origin area. And that insertion is very small. So when you're actually going to be contracting this muscle, for example, yes, you're going to have a good length of contraction, but because there's so many fibers, because it's so large, then guess what? You're going to have a great strength of contraction as well. So you're going to have good both length and force here because of the way it's shaped. The origin is very large, and there's a lot of muscle fibers that are very long that are coming to this one little insertion point. Because there's so many of them, they are going to have that very strong contraction. And also because they're super long going to this one point, again, you're going to have a very long contraction. That's what we're thinking of. So convergent is going to be both already. That means it can do both. Now we have circular, or we can also call these sphincter. Okay, these are going to wrap around an opening in the body. So an example here is going to be orbicularis oculi, or orbicularis oculi, excuse me. And that means that we're talking about something that's circular around the eye. So as you can see, these fibers, they're going to run in a circle. And of course, there's not many of them, but it's a good amount, right? What's the whole purpose of this? It's fibers that are around the eye, for example. So we've seen this one, we've seen this one. They're going to contract to close that opening. So if you squeeze your eyes down right now, you are actually closing your orbicularis oculi, and that means you're contracting that muscle around the eye to be able to close your eyelids and keep them closed for as long as you can, right? So let's think about this. That means you're going to be squeezing down on this sphincter, or this circular muscle. It's going to get smaller, and then it's going to close this opening here, okay? So anytime you think of something that's going to be circular, definitely think of, you can call it a sphincter, or again, just say it's a circular fascicle arrangement, and all the different fibers are around it. And yes, they can be long, because if I was to cut this and to extend it out, it will be long. But again, we're talking about it being like a circular shape. So all of these are long fibers, parallel and their subform, fusiform or spindle shape, convergent and circular are all going to be long fibers. And so the contraction length is going to be a little bit longer. Of course, those long fibers can be different types of shapes. So you can have long and thin, like we saw the sartorius muscle here. We can have spindle shape, like we saw at the bicep brachii. We can have, again, convergent, which is very large, like we saw the pectoralis major. And we also can have a circular muscle, which is going to be, again, like the orbicularis oculi here around the eye. You can also think of around the mouth. You can also think around the anus as well. Anywhere you can think of an opening for a sphincter to be. And these all run the length of the muscle that it is referring to. So the length of this muscle, the length of that muscle, the length of this muscle, the length of this muscle as you go around in a circle. Now let's focus on the number of fibers. The only one of these that mainly we're going to do talk about the length and the force was convergent. Yes, we have the bicep brachii that's also going to have the ability to be fatter in the middle to kind of increase some of that force of contraction. But the one that truly does both is going to be convergent. Right. Number of fibers, or again, strength of contraction, meaning how much force is generated from that contraction. Well, as you can see, all of these words here have one thing in common, and that's going to be the word pinnate. So we have pinnate, bipinnate, and multipinnate. You can also call this unipinnate as well, just to kind of keep the, thing going, like uni, bi, multi, but you can also just call it pinnate by itself. And it just means feather. Okay, so it means feather. And as you can see, we have a feather here. And that means that you're going to have some kind of tendon that's going to have short muscle fibers that are coming out of it at an angle. And that means a lot of short muscle fibers, because we're talking about strength of contraction. So these short fibers are going to run at an angle from one side of a tendon. That's what we call it unipinnate. One example is extensor, the extensor digitorum longus. See down here. As you can see from the name itself, extensor digitorum longus. Extensor means the action, so it's going to extend. Digitorum is probably digits, as you can see, is going to be the toes here. And longus means that it's very long. Okay, and this is going to be a unipinnate or pinnate type of muscle. So a lot of fibers, meaning very, very strong contraction, but again, the fiber length is very short. Now let's get into bipinnate, which means that the fiber is going to extend from both sides of a central tendon. So as you can see here, we have a tendon here, and we have our short fibers coming off of it. We have lots of short fibers coming off of it, because again, this is very, very strong contractions. One example is going to be our rectus femoris, and rectus means that it's kind of going to be going down straight. Okay, so you can see that our fibers are kind of going down straight, and then femoris means around the thigh. So you can see that here, the rectus femoris. And once again, the specific thing you need to be looking for is, how does those fibers look? Are they long? The answer is no. Are they short? The answer is yes. Okay, are they going to be short where they're short on both sides, or is it just on one side? Well, again, we see that's going to be on both sides for bipinnate. That's where the bi comes in too. Next, we have multipinnate. So the fiber is going to extend from branch tendon. Okay, let's think of the deltoid muscle. So our deltoid's up here in our shoulder. That's a little shoulder cap muscle. And as you can see, we have our different amount of tendons running through. So we have a tendon here, a tendon here, here. We have more tendons running through as well. And each of those fibers are showing that that tendon is going to branch out. And for each of those branches, they're going to have different bipinnate type of structures. So that means we're going to have different tendons coming here, one tendon branching out and creating, again, the short fibers. So multipinnate means, yes, you're dealing with something that has a very strong contraction, because not only we're dealing with one tendon, we're having a tendon that's going to be branching out to create multiple forms of that same tendon, that's then going to pinnate. Whether it's going to be bipinnate or unipinnate. Either way, you're going to have so many short fibers coming together. That means you're going to have very, very strong contraction. What we're saying this is you're going to have multiple tendons all having short fibers at an angle that's going to contract with more strength. So let's go ahead and get into a couple of examples to understand our fascicle arrangements. Or again, think about movement. When we're talking about movement, of course, it has to do with contraction, because we have to shorten that muscle. And the fascicle arrangement is going to tell us whether that contraction is going to be very long, or is it going to be strong, or both. So let's go ahead and get into an example here. The first example says, below is an image of the muscles of the back and a cadaver. So again, we are talking about the back. It also shows us that we have an origin here and an insertion here. So we have an origin, going to be pretty long, and then we have an insertion. The infraspinatus is highlighted. So this is the infraspinatus muscle here. It's a part of our rotator cuff. As you can see, it runs along the actual scapula here. The origin is going to be kind of the medial border of the scapula, whereas the insertion is going to be at the proximal end of the humerus. So now that we're grounded, let's go ahead and answer the question. Based on the image, what type of fascicle arrangement does the infraspinatus appear to have? So we can go back and say, okay, let's think about it. We know we're going to have a large origin, very small insertion. The only one that does that is going to be convergent. The origin is larger than the insertion. So we know we're going to have convergent. So that means you could have a note card that has all the different fascicle arrangements and have it in your brain to be like, oh, convergent, okay, this is going to be fusiform, or parallel, or bipinnate, etc., etc. Now, is this fascicle arrangement optimized for force generation or for range of motion? Well. Basically, it's saying, is it going to be range of motion based on the length, or is it going to be force based on the number of fibers? Okay. Now, when we talked about convergent, what did we say? We said that they are both going to be optimized for length and force, because there's a lot of fibers, and we said that the length is very long getting to that insertion point. So you can write both here. Of course, you can also write range of motion and force. Whatever way you want. But writing both is just the easier way. So that's just one example of how you can kind of start understanding fascicle arrangements. Let's get into another. 4 muscles are shown below. Boom, 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 boom. Based on their fascicle arrangement, which muscle doesn't belong in the group? So we're saying that basically one of these don't belong in one single group that we're talking about. And so what we're going to look at is go back to our actual fascicle arrangements. You see that we're talking about length of fibers here and number of fibers here. So that means either you're going to be a part of the number of fibers group, or you're going to be a part of the length of fibers group, or it could be, again, both, if you're talking about convergent, specifically when you're talking about the strength of a contraction, not what it looks like. All right, let's go ahead and think about this. Rectus abdominis. Rectus means straight. Abdominis means you're talking about the abdomen. And so as you can see, I see that the muscles are basically going into a straight parallel line. They look parallel. So because they're parallel, that means that we have one group there. Okay, and they are going to be optimized for what? Range of movement. Then we have the interossei. And as you can see, we are dealing with the foot. And we also have tendons here. Tendon, tendon, tendon. And they look like they're going to have short fibers coming from both sides. So that's obviously going to be bipinnate. Now, some folks will be like, wouldn't it be multipinnate? It'll be multipinnate if that tendon is branching. So you have one tendon that's branching to, again, or you can have multiple tendons that's branching. But these are individual tendons, you can see, that are then branching out bipinnate. So that's how we say bipinnate then. Then we have the bicep brachii. And then we know it's going to be our upper arm muscle. And as you can see, the shape of this muscle is that, yes, it's very, very long, but also it kind of has that fatter middle portion. So we know it's going to be spindle shaped, which means we're dealing with fusiform. But remember, fusiform was a subgroup of parallel fibers. So automatically, rectus abdominis and bicep brachii are part of the parallel. So just without looking at number 4, you will be like, okay, letter B is somehow different than the other groups. Let's go ahead and look at letter D, sternocleidomastoid. So again, we're going to have our origin here, and we're going to have an insertion at the mastoid process. What do we notice? We notice that we have just long, straight fibers here that are parallel. And so again, we have another one that's going to be in that parallel group of fibers. So we have 3 that are in parallel group of fibers, and 1 that's a bipinnate. So obviously, this is the one that does not belong in the other group. All right, folks, let's go ahead and end this video, and then I'll see you for our next video, which is all about naming muscles before we get to our muscle list. See you there.